Alright, today's lecture is going to be about assemblies, as you see here. So we're going to work on putting this thing together. Let's see. So you are given some files. Let's extract these and see what we got. So we got a little movie as well. And we're going to work on assembling this. We're going to import these parts. These are all models, part files. We're going to import them, mate them. Okay, there's all kinds of mates in here. There's a gear mate, there's a concentric mate, a cam and follower mate, and we're going to work on putting that together. So that's the core exercise. This is going to help you for homework 5, which is to assemble an arbor press. So we're going to take this tutorial one step at a time and proceed. So again, there's the parts, but you got to build the assembly. So I'm going to fire up SolidWorks and I'm going to create a new, not part, not drawing, but assembly. So again, like we've already talked about, you want to make sure that your units, tools, options, okay, make sure that your standards is ANSI and then your units is IPS. Okay. So we're going to start by importing the models onto this assembly. First, let me save this. And we're going to use the insert component tool to insert the models. As part of the start files, you are also given a bill of material. So on the next lecture, I'm going to teach you how to build this, but for now, just use this to see what connects to what. So we're going to start with number 10, which is the assembly base. I'm going to browse for... okay, so yeah. So assembly base is the first item we're going to bring in. And it's an assembly. So isn't that interesting? You can import an assembly onto an assembly. Okay? You can import a part or an assembly. So that's a very important concept. Because when you design a really complex machine, that's actually what you do. You don't just import all the parts into one assembly. It's going to cause all kinds of problems. Instead, you create a subassembly of the electrical panel, and then you create a subassembly of the hydraulic system, and then you import all of that into a master assembly. So here's an example of this assembly. Okay, so as you can see, I can open this and I have access to the two pieces. So I'm guessing this is a welded piece. This gets welded into that. So it makes sense, instead of making this one piece, say, hey, this is two pieces that are machined or bent, and then you weld them together. Okay, so to do that, you use an assembly. Okay. But when you import the first piece in SolidWorks assemblies, you need to make sure it's in the center. So the origin is over here. See, this is the origin, but we imported it there. It needs to be in the center. So there's multiple ways to do this. The first way is, let's say we were to import this. If we import it, if you just click OK, let me see here. See, it automatically centers it. That's if you don't touch the graphics area. It anchors it directly onto the center. You just click the checkbox and it does it. But if you want more control over that, you gotta hit float. The first part in an assembly is always fixed by default. Every part after that, it's floated. But if you want to move the first part, you gotta float it. The reason it's fixed is because it needs a point of reference for the other parts that get mated onto it. If everything is floated, it has a very hard time doing anything. So anyways, you float the first part, and then you mate each plane. You see what I'm doing here? Right, hit mate. Top, hit mate. Okay, you mate each plane so that it's anchored to the center. This is really the main tool we're going to learn today. It's called the mate tool. And when you add a mate, it connects pieces. It's like a three-dimensional relation. See, these are all the mates. I just added 3 mates, 3 coincident mates. They're also saved in this folder. So these are all the mates for the file. These are all the mates pertinent to this model. And you can modify these anytime. You hit edit feature and you can change the mates. Either it's parallel mate or perpendicular mate. Okay, just like a relation. It's just a 3-dimensional relation. For subsequent pieces, we're just going to look at this diagram. Okay, I'm going to work on this handle. Alright. So, actually I'll tell you what, to make this easier, I'm just going to import everything. And we're going to figure out where each of the pieces are going to go. So I'm just going to hit Insert Components. And I'm just going to box select everything. Except for the, well, I'll just pick parts, yeah. And that should be everything. And then I'm just going to lay it down a bit. And we're going to figure out where each of these pieces are going to go. So some of these are custom pieces, some of them are off the shelf. So that's very typical of most assemblies. Some pieces are off the shelf, some others are custom. Alright, next thing I'm going to do is I'm going to turn off, I'm going to go to View, Display, hide all types. See this? Hide all types? Just because those construction lines are kind of in the way. And then I'm going to work on this handle like I talked about. So I'm going to hit Mate, and I'm going to pick this surface, or it can be this surface, anything that's concentric, and then pick this surface. So you see how it's kind of connected, but it's not in the correct direction. So to switch direction, you gotta hit this button here. See that? That's how you're gonna switch direction. So now you move it here, and I need not only a coincident mate, but also a, well, not only a concentric mate, but also a coincident mate. So concentric means the axis is shared. Coincident means that they touch. So this needs to touch with this. So this needs to touch with that. Oh, it didn't save. All right, let me do that again. Where did it go? Okay, there it is. All right, let's do this again. Actually, let me show you a better way to do this. First select the 2 pieces, then select mate, and it's going to figure out what you want. Click the green checkbox, and now we're going to add the next mate. Surface to surface, and it's going to figure out that you want a coincident mate. Alright, just like that. Let's add the bolt. This bolt. Pick this surface. Don't pick the threads. You'll get problems. This surface is a good concentric feature. Also, try not to select edges or points. They're not strong surfaces. Pick like a surface. Surface is a stronger connection. Okay, then there's a spacer in between those. There's the spacer. See? Select a surface. And it kind of figures out what kind of mate you want, which is very convenient. And then you have this piece. This is called a universal joint. It lets you transfer torque in a different direction. Okay, so let's see what we got so far. If I do a section view, you see what's going on here? You got a bolt. It clears through this piece and that piece, but fastens on the last piece. So it sandwiches the assembly. And you see how much clearance is on this middle piece? And that's a good design, because you don't want to over restrain your assembly. The only purpose of the spacer is to allow enough space so that there's enough thread engagement. If you don't have the spacer, this bolt is going to bottom out on this universal joint, and it's not going to sandwich. It's not going to compress the assembly, so that's not going to be good. So that's how you use the mate tool, and all the mates that I created are saved here. And you can modify any of them. You right click and hit edit feature, and you can modify any of these any way you want. And all the mates are saved individually within each piece as well. So when I try to rotate this, what you'll notice is that it's not rotating the handle. Okay, so we need to connect them. A cheap way to connect two pieces is just to, if you select both of them, you can hit lock. But I don't like doing that because it connects them at an arbitrary angle, which is not really good. So instead, what I like to do is just, I just connect the planes instead. So that's a much better way to do that. You see, you just connect the planes and then you hit mate. Now they're connected. So now as you can see, when I'm rotating it, the universal joint is rotating with it because the planes are connected. Alright, so let me work on the other side of this assembly. Again, you just assemble this the way that you would in real life. You don't have to think outside the box. It should be pretty straightforward. Okay, here's a little trick for you. Instead of re-importing this, I need another one of these. Instead of re-importing it, drag and drop. Hold control, drag and drop. And it gives you a copy. Alright, so now I'm going to mate this onto this, and I'm going to flip the direction. Alright, there we are. Okay. I'm going to mate this surface onto that. Okay, good. This is the snap ring. It's gonna go inside here. And then this is gonna go inside. So really, a lot of these parts need two mates, the concentric mate and the coincident mate. Now I'm going to add a universal joint mate. Okay, this is just a setup. I'm just adding two parallel mates to make it cleaner. These are just temporary mates. I'm just going to delete them now. Okay, it's just for staying clean. Okay, I'm going to delete these. Just going to hit delete. Alright, now, here's a new kind of mate. This one's a universal joint. And the way you add it is you gotta click on universal joint and pick two concentric entities. Alright, one here, one there. And then click OK. So you see how the two rotate now? This is because we applied the universal joint mate. Alright, what I'm going to do now is work on another special mate here. I'm actually going to delete the coincident mate that I created. I don't need that one. It actually needs to float. So I'm just going to delete that one. Alright, I want it to kind of slide and stop there. That's another kind of common mate that you need in design. Oh my god. Okay. So here's how this mate works. This is called an advanced distance mate. You pick the minimum distance and the maximum distance, 0.083. And you pick where that reference is. Alright, and you click OK. Okay, you see what's going on? I'm dragging, and then it stops. Alright, so that was through that advanced mechanical mate. Alright, from here I'm gonna clean this up and just kind of repeat what I did and just continue building this. I'm very careful on the mates that I apply. Okay, if you over restrain it, it's gonna give you all kinds of problems. So you have to be careful. Really, you restrain this the way it would be restrained in real life. Okay, so I try to add the concentric mates first because it's better. Sometimes I like to pre-rotate the piece so that it fits better. So that I don't have to like switch the direction of it later down. Oh, actually this was not correct. This needed to be connected to something else. Let me see if I can... Alright, I need this to be connected inside, but I don't want to just connect the surface like this. I don't want to do that because then I put some error on the side. It creates a bias. And if you're off by just a tiny amount of inches, like 0.00001 inches, it's going to glitch out and it's going to give you an error. So to avoid that, what I like to do is I like to connect the planes. If they're symmetrical, I like to connect them to the center planes of the model. So now, as you can see, the error is symmetrical. But I still need to fix this one. So what I'm going to do is I'm going to delete this one. This one was not correct. This one needed to go in here. And I'm going to do the same thing with this. I'm going to connect this plane with this plane. And then this one is going to fit inside here. And then for this nut, I'm going to select this edge. Alright, you can try selecting the threads, but it's going to give you problems. So personally, I found that edge to work out pretty well. Ideally, I should select the axes. Okay, that would probably be the best thing to select. As you can see, that's what that looks like. I need another one of these, so I'm going to hit Control and drag. And I'm going to build the rest. I need another one of the bolts, so again, I'm going to Control, drag, and drop. Let's see. There you go. Oops. Again, I don't like selecting edges, but it's kind of hard with the hardware that I have. Okay. Okay. Okay, here's another new mate here. If you look at this cam, it's 0.25. You see that? So 0.25 on the back. All right. This is a standard mate, but it's this one. It means it's press fit 0.25 from the back here. All right. So now we need this one. This one's gonna go in here. And it's gonna go sit here. Okay. And this one needs to connect with that. And we need another one of these. So control, whoops. And this one's gonna go here. Oh my gosh. It's very weird that it just, I'll just select it. Oh. It's very weird. Not sure what's going on. Jeez, that was crazy. Alright, this one's gonna go here. And then this is gonna hit there. I'm gonna flip direction. And then this one, that's there. Okay. And it needs another bolt. Okay. Sometimes it digs inside the model, which is not good. So sometimes I do the coincident mate before I do the concentric mate to avoid that. See, this is not a really good design because you're holding this piece with one bolt. Because sometimes this tends to unwind, which is not good. Unless you have like a left-handed thread like on a lawnmower so that it always tightens when it rounds. But if you want to avoid unwinding, you can put either two bolts or you can put like a lock pin like you see here. Alright, now we need the collar. We need this, okay, it needs to hit the top surface, otherwise it's gonna fall off. This is a panel nut, as you can tell by how much shorter it is. It was right in here. Ooh. See, that's what I'm saying. Sometimes it hides inside and that's not good. So instead what I'm gonna do is select that surface. And then I'll do the concentric mate after. Alright, we got a gear here. There's gonna be one there. And we're gonna set that there. And then I'm gonna go duplicate. I don't know why it's giving such a. Okay, there it is. And then we're gonna put one under it. Okay, so now we got the pieces, but as you can see, nothing's connected. So now we got to work on connecting all these pieces. Alright, so now I'm gonna work on connecting. So let's see what we got. Okay, good. This needs to connect with the central shaft. Gets a little tedious finding the pieces, but that's the way it is. Oh, there it is. Okay, you gotta pick a plane that's sharing the same axes. So that's good. So now this rotates, but this is not attached to this. So we're gonna attach those two. Alright, this is good, but now we gotta connect it to this. So here's a new mate. It's called the gear mate. Let's take a look. Gear mate works like this. It's a mechanical mate. It's called gear. You pick a concentric feature of one gear. You pick a concentric feature of another gear. This is a 1-to-1 ratio of the same gear. Otherwise, you can do 1-to-2, 1-to-3. You click OK. Now, as you can see, the gears connect. So that's connected. Now this needs to connect with this. This needs to connect with connected to that. Then this connects to this person. And then, yeah, and then that connects to that. Okay, good. Now we have just one final mate, which is this gear and follower. So this is a very important mechanism. That's how the timing is done on your engine, actually. When you exhaust and you insert oxygen, it's not done with a PLC. It's done with gear, a cam and follower. There's the follower, there's the cam, and as it rotates, it does all the timing. So let's go. Okay, it's called a cam. All right, you gotta pick the follower and you gotta pick the cam. So this is the follower and then this is the cam. You gotta pick like that point. Okay, I see what's going on this. On the 2020 version, I believe you just need to select once, but if you're using an older version of SolidWorks, you gotta go all the way around. So there's the connection. Let's see what happens. There we are. You see how it's moving along the cam? The reason it's not connected because this is not connected to the central shaft. Pretend it's a press fit. Okay, that's how it's. This is held by press fit. This is held by a set screw. Okay, this is held by a screw over here. So we got a lot of variety on this design, but that's really the idea. You see this? That's the final product. That's how you create an assembly. So really, the only tool we learn is the mate tool. Okay, but you gotta understand how to connect all the pieces so that they are working properly. There's no errors. There's no over restraints. And everything is centered about these central planes. You see that everything is well centered. So you gotta pay attention to that. Because when your models get more complicated, the cleaner you work, the more organized you are, the easier it'll be down the line. So anyways, that concludes assemblies.